Guys, welcome to my channel, and today topic is reverse osmosis. So this is a part of desalination of brackish water, and this is the ninth video in water technology. You can find all my previous videos in my channel. The corresponding links was provided in the description. Please follow it. We all know our globe is occupied by 3 by 4th of water, and in that water 97% of water is salt water. This water is not suitable for drinking purpose as well as industrial purpose. Only accessible water is 0.14 percentage water only is accessible for drinking purpose. So we are surrounded by most of the salt water. The water containing dissolved salts which peculiarly salty taste is called brackish water or saline water. Simply, sea water is called brackish water. The removing of common salt NaCl from the sea water is called desalination. So desalination can be done by two processes. One is electrodialysis and reverse osmosis. Today we are going to discuss about the reverse osmosis for desalination method. So before going to reverse osmosis, so we need to study about osmosis. So what is osmosis and why it is happened? So the spontaneous flow of water from diluted to more concentration side through semi-permeable membrane is called osmosis. So in particularly you can say like this, the spontaneous flow of solvent. So I said water, but exactly solvent present in the solution from diluted side to concentration side through semi-permeable membrane. So what is semi-permeable membrane? Semi-permeable membrane is one which permits only solvent molecules through it. So that means from if you separate the solution from left to right or right to left, only solvent molecule only can access to go through the semi-permeable membrane. So solute particle passes will be prevented by the semi-permeable membrane. So for example, if you keep the grapes, dry grapes into water, they will become swollen because of water enter into the dry grapes. Okay, if you keep the normal grapes into concentrated salt water, they shrunken gaps, they become shrunken. Why? Because the water present in the grapes is come out into the salt water. This type of process is called osmosis. So both are called endoosmosis and exoosmosis, but whatever total phenomena is osmosis process. So semi-permeable membranes only allow the passage of solvent molecules through it. Example for semi-permeable membranes is cellulose estate, polyamide, egg membrane, goat's bladder. Of course, our skin also act as a semi-permeable membrane. It only allow the solvent molecule in the form of sweat from body to outside, if you can observe every day, right? So these are the semi-permeable. Let's see what is osmosis. So when you separate two concentrated solutions by semi-permeable membrane, so for example, if you take a U-tube shaped tube, and it is a here semi-permeable membrane keep at the bottom of this bottom and center of the tube, and this side having a low concentration side. Low concentration side mean solute particles having less number present in this solution. Here more solute particle, that's why it is a concentration solution. So when you separate these two solutions by semi-permeable membrane, now we know semi-permeable membrane only access to passage of water molecule. Okay, so either from left to right or right to left, only water molecule can move. Okay, but which movement is possible at this situation? So if you see here, only diluted side too. This is diluted side and it is concentration side. Water molecule, that means this H2O molecule, H2O only pass from the diluted side to concentration side. This phenomena is called osmosis. It is a spontaneous process. We no need to apply any external pressures. So why it is happening? why the spontaneous process is happening. If you observe the both sides, this is diluted side, this is concentration side. Here number of solute particles is very high, so they are not comfortable, they are very less space, so they have some pressure between the particles, so they have colliding each other, they are not being comfortably. If water molecule, so if water molecule come from left side to right side, the volume of the solution will increases. If volume of the solution increases, the space is more provided to the particles. When the space is more, the colliders or their pressure will be decreased and they feel comfortable. So like that, every object in the universe wants to be stable, wants to be flexible, wants to be comfortable. That's why this they allow the passage of water from, they are forcing the passage of water from diluted side to concentration side. So this is the osmosis process. But what can I do here? At the concentration side, I kept a cap, or I prevent the passage of water by keeping something. That means I am applying pressure here. So to stop the osmosis process, to stop the natural spontaneous osmosis process, then now, even though this is concentration side, this is diluted side, so the spontaneous process will stop. Why? Because I am not allowing any water by stopping, by keeping this one, the osmosis process stopped. So how much pressure is here applied, that is used to stop the spontaneous process, thus pressure is called osmotic pressure. So osmotic pressure means the pressure required to stop the spontaneous osmosis process is called osmotic pressure. This is the one case. If you observe the next case, so here I am not only applying pressure of osmotic pressure, I am applying pressure more than osmotic pressure, and I am forcing to move the solvent molecule from concentrated to side to diluted side by applying more pressure than the osmotic pressure. I am applying more pressure than the osmotic pressure at concentration side. This is very important. Here two things you need to observe. One is how much pressure I am applying. I am applying pressure more than osmotic pressure, and that too, that pressure is applying at the concentration side. Now only one chance is there, water molecule has to move. You are applying pressure this side, definitely this side water molecule only moves from concentrate side to diluted side. So here osmosis, if you observe the osmosis, so diluted side to concentration side water molecule is moving. This is spontaneous process. But when you applied more pressure than the osmotic pressure, now the movement of solvent molecule is reversed. This process is called reverse osmosis. So if you apply this process to seawater desalination purpose, so here it is a vessel. This vessel is separated by two parts by the semi-permeable membrane. This is the semi-permeable membrane. It only allows the passage of water molecule. Upside you take in the seawater. Seawater means it have a NaCl, that is a solute particle, and water, that is a solvent molecule. So NaCl plus water is there. So when you applied the more pressure than the osmotic pressure at the top of the concentration side, here you are applying a more pressure than the osmotic pressure, and the on the concentration side, now only water molecule only move from the concentrate side to diluted side through semi permeable membrane. Like that you can separate water molecule from seawater, but salt still stay on here only, so you will not able to get salt in the fresh water. So this movement is not possible, only water molecule only moves here. Like that you can separate the water from salt water, so you will get, finally you get a fresh water. This process is called reverse osmosis for desalination method. Here you can observe, you can say this is the super filtration or hyper filtration. We can say in normal filtration we only separate the in we only separate the visible solute particles, but here non-visible ions also separated by this filtration. That's why this filtration is called super filtration or hyper filtration. And what are the applications and advantage of this process? This process we can remove ionic, non-ionic, colloidal, high molecular weight, whatever is there. If it is solute, it will be separated by the semi-permeable membrane, and semi-permeable membrane lifetime also very high, and we can easily replace within minutes. We can replace the semi-permeable membrane, and we there is no uninterrupted water supply. So there is a uninterrupted water supply. There is no need to take much time to replace the membrane. So capital cost is also very low. It is also compact unit. We can use in every home nowadays having a RO. We are seeing in advertisement also. RO means reverse osmosis. So according to WHO, if your water having more oddness causing salts or more TDS, total dissolved salts, if you use the osmosis, the reverse osmosis process, you will get a WHO specified water. That means less than 500 ppm dissolved salts and less than 300 ppm hardness causing salts. So this is extremely used for the power plants and different industrial purpose. So this is the reverse osmosis process. We can separate the salt water from the sea water. So this is the topic. Thank you for staying with me. Thank you very much.